Welcome back. We're talking about collections in this lesson, and I'm going to do this in two parts. First, I'm going to discuss arrays, and in the second part, we'll be discussing dictionaries. And actually, I think back and forth between playgrounds and this presentation. So, what is an array? So basically, we've been looking at simple variables that can hold one value. An integer, maybe a grade, it can hold one grade. A string name can hold one name. So what an array does is it can hold multiple values of the same data type. And this is really useful. For example, let's say that I have a class list. I'm teaching the class and I have 20 students. I don't want to create 20 variables. I just create one array that can hold 20 names or 50 names or 100 names, how many ever names I wanted to hold. There is no, it just holds infinity names. And so, again, it has to be of one data type. So an array can be of all integers, an array can be of all strings, all doubles, all booleans, etc. So here we have an array called names and is of type string, and currently it holds 1, 2, 3 elements, and our elements are names. We can define arrays two different ways, just like our simple variables. We can give it the data type, or we can leave the data type out and let Swift figure out the data type. This is not a problem most of the time. This is what you want to do unless, for example, you have averages. Let's say you want to store averages, and sometimes your averages could be integers like a 90, or it could be doubles like 90.5, a floating point number. And so in that case, you want to definitely define the data type to be double, especially if you're going to be adding values to an array as you're running the program. So, you calculate the first student value, and the first student value is 90, and the second one is 90.5. You want to tell it that you're expecting doubles. In your book, it talked about another case is if, for example, you wanted integers that are small integers. So in your book it was saying an int can hold positive and negative numbers that exceed beyond a range. Like, let's say you wanted the range of an 8-bit integer, which is negative 127 to positive 128. Let's say that is what you were expecting, and you want Swift to give you an error if you get a number that's less than negative 127 and greater than 128. And so what I did here is, because your book introduced this small integer called int 8, I wanted to show you how to figure out values, the range of values for a particular data type. So if I say let min value equals int.min, this is going to return the lowest integer and the highest integer that my particular system is capable of holding. If you're running a 32-bit system, it's going to be a smaller number than what you see here. So here, if I put 8, no matter what kind of system I'm running, it's going to show negative 128 as min and 127 as my max value. There's also a 16-bit, like that, and that shows you min and max. We don't typically do this. There's no reason to ever do this. We used to have to, many years ago when I started programming, we used to have to be really, we had to be mindful of how much memory we used. So we would use small integers if we knew that we needed a small integer, so that we would not take up a lot of memory. Now, memory and storage are both huge and plentiful, so we don't have to worry about that. But there might be, for some reason, you might be working on a device that you have to be mindful about how much memory or storage you're using, and this is where this would come in handy. But most of the time we don't worry about it. We just define everything as integers and doubles. There's also, like with doubles, there's also smaller doubles, a pretty big, it holds a big floating point number. There's also a smaller one than using doubles. And in Java, it's floats. I'm not sure. Let's see. Yeah, in here too. So in Swift is a float. So you have a float 32, 64, 80. So this is floating point numbers. And again, if you're worried about how much memory you're using or storage, then you would decide the size that you want to use. Okay, so I'll leave this as int. And notice when I did that, we have 8, 16, 32, 64. And just a regular integer. Okay. Spend a lot of time on that, but we're not. So here they're just saying go ahead and tell it that you want to define it as an int 8 to make sure that you're not able to go beyond 128 or less than negative 127. Okay, so we're going to talk about some properties that you can use with arrays. One of those is called contains. So when you have an array, you can ask and say, does my array contain, and you pass it a value. If these are strings, you can say, does it contain the name Joe? And it'll tell you yes, or the number 5. So contains is used for searching. If you have an array of names, and you're searching for the name, you use contains. So it returns a Boolean, true or false. If it contains it, it's true, and it prints the 5. See, I don't think I did a contains, no. Okay. These are different ways that you can define an array. We're going to use the very first option here. So we're with arrays, typically they most of the time they are created as variables because we want to be able to create empty arrays and add to the arrays. We want to be able to create an array and delete, add, modify. So we have to create it as a variable. If you create it as a constant, then you can't change it. And there are times that you do want that. So here we have an array that is an integer array, and it's empty. So by having open and closed brackets with nothing in it, you're defining an empty array. Here is my same thing. So I have var my array equals int. And let's say that I didn't want it to be empty. I wanted to say, okay, I want this array to be max 100 elements, and I want to initialize it all to zeros. You can type 0, 0, 0 and do it 100 times, or you can say repeating :0. So this is what you want to initialize it to, and this is how many elements you want. You want 100 elements of zeros. Count property will return how many elements are in your array. So count here will return 100, and is empty will return a true or false to tell me if the array is empty or not. So I did type this one here, and we are going to do that. Okay, so here we've defined our array. It is not empty. It has 100 elements. And then okay, so here notice on the right hand side it has 0, 0, 0, 0. It's going to be 100 zeros, and then count is 100. Now if I take this out, okay, figure out, and there we go, Command X. Okay, so I deleted that code, and so now I have an empty array, and my count is 0. And remember, you can do the parentheses. That's one way to define an empty array, or we can do the square brackets. I'll type int. Why does it not like that? Oh yeah. Okay. Sorry about that. Forgot to change it to brackets. Okay. So we can use the parentheses or we can use the brackets. There's nothing wrong. Oh yes, there is something wrong. My goodness. Here we go. Where's the colon? Colon, int. Okay, now it's happy. So we can initialize it like this, colon int, or equals, and then the parentheses. And then here count is 0. Now we have the if empty, so we say if my array is empty, then do something. So we could say print it is empty. And so here at the bottom, you see that it prints it is empty. See on the right hand side. Now if in here I put 2, 3, 4, and it runs again, Let's not say it's empty. I could say else print is not empty. And it says system's not empty. Okay, so we have the is empty. We have the count. So here count, notice, is 3 because we have 3 elements. Okay, so those are really useful. These are super useful in programming. You're going to use these all the time. String manipulations. Okay, so we have is empty, count. Working with arrays, accessing or setting a specific item. Okay, so when we're working with arrays, we talked about elements. So Annie, Gary, and Keith are elements. Each element is in a specific index place. The index of Annie is index 0. Index of Gary is 1. Index of Keith is 2. And the reason this is names has a specific, when you create names or a variable, it grabs memory, right? It grabs a memory location. We talked about that a little while back. So let's say that memory location ends in FFE0. This is where the memory location ends, FFE0. To find Annie, you add 0 to that. So Annie is at FFE0. Gary is at FFE0 plus 1, so you add 1 to Gary. Now, in reality, you're not just adding 1, you're adding you're taking the 0, you're multiplying it times like the size of, this gets really complex. So if it's integers, you multiply times the size of the integer, and then it holds that much space for that integer, and then it moves down 2 times. An integer moves down that much 3 times. So the reason the index starts at 0 is because of the memory locations, and it does math, it does some calculation. If you're interested in more about that, I can post a video about it. It's actually very cool and interesting if you love this kind of stuff. And so here we know that Annie's at 0, so we're going to take names of 0, we're going to assign it to this constant that we created called first name, and we just print first name and it prints Annie. So names of 0 is Annie, name sub 1 is Gary, name sub 2 is Keith. Here they have changed, they're going to change name sub 1 to Paul. So Gary is going to be replaced by Paul. And now you have Anne, Paul, and Keith as your array because you replaced element number 2, which is index 1. Okay, so let's take a look at that using playgrounds. I typed it in here. So we have var names, a variable array called names. It has 1, 2, 3, 4 elements. And, oh, I don't want to do that yet. Okay, before we look at insert, if I do print names sub 0, it's going to print Amy. I need to learn how to type. There we go. Okay, so print name sub 0. And let's take this stuff out of here. I don't want to see this. Okay, so Just like that. Okay, so in Java and C++, this typically works. I'm trying to see why in Swift it does not. Okay. Well, I'll look at that later. We'll just take out each line separately. I'll figure out later why this blocking comment's not working. Okay, so here we have print names of zeros Amy. Then we can say names sub 1. So name sub 1, well, we know name sub 0 is Amy. We know name sub 1 is Brad. So let's just change name sub 1 to Mark. And when we change it to Mark and we print names sub 1, we should now see Mark instead of Brad. Okay, so index 0, index 1, index 2, index 3, and these are called elements. We have 4 elements. Okay, going back to here. We have another property called append. So append will add to the end of your array. And so here we have Amy, names that append Joe. So now you have Amy, comma, Joe. If you do plus equals Keith, comma, Jane, now you have Amy, Joe, Keith, Jane. Okay. Insert, you can insert at a specific location. So here you're inserting Bob at 0. So Bob would now be in front of Amy because Amy is at the index 0. So it moves Amy to index 1, Brad to index 2, index 3, index 4. So inserting at a location would be like, for example, you've got a list again of names and they're alphabetized, and you figure out by looking at them, you're like, oh, I've got to insert, this name. Let's say it was Bob. I got to insert it between Amy and Brad. Then you could insert it at that location at 1. Okay, so that's inserting. Removing, we can remove at a location, and we can remove the last element, and we can remove all the elements. So names dot remove at 2. So there's 2 things I can do. I can not assign it to anything. I can just say names dot remove at 2, and it gets rid of it, and I lose it forever. Or I can remove it and assign it to a variable or constant, and then I have it. So again, you don't have to say equals, you can just remove it. Same thing for remove last. You can just say names that remove last without doing let dan equals, and then it's lost forever. So let's see here. I can do remove names dot, and again, this is nice, so I can say names dot remove all. I don't want to do that. I just want to remove last, and there's remove last right here. So again, if you forget what properties you have available, type the name of your array and it'll give you those. Maybe you remember what it begins with. So we have remove all, remove at, what location, remove last, remove first. Okay, so we're going to use remove last. And so now since I removed last, I'm only going to have Amy, Brad, Chelsea. Well, actually I'm going to have Amy, Mark, Chelsea, right? So let's print out names, or let's just look at names dot names sub 0, names sub 1, names sub 2. Okay, so names of 0 is Amy, names sub 1 is Mark, because I changed Brad to Mark. Names sub 2 is Chelsea. Now let's print names, or let's just look inside name sub 3. We're not really printing it, just looking inside of it. So if I do name sub 3, I had Dan at name sub 3, but I no longer have it because I removed it. And so I'm going to get some errors. And has all kinds of so you can kind of see what the errors look like when you index into something that does not exist. So you're indexing into you're indexing into a memory location that doesn't exist, name sub 3. And by the way, these here that you see here, these hexadecimal numbers, OX, blah, 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 these are memory locations. Okay, so it says, no, 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 don't do that. I don't like it. By the way, inside these things too, you can do things like, you can do, well, I say that in other languages, and hopefully in Swift you can do 1 plus 1. Yep, it likes it. So you can do math in here, and we'll do that later on. We can also put variables. When we learn how to do loops, we'll do a loop that runs through 0 through, let's say, 100, and you just print let's say x in here, and then it goes, and x changes from 0 to 100, and you don't have to do names of 0, names of 1, names of 2. You just put a variable and run it through a loop. Okay, so those are some cool things about arrays. And so we can remove, and we can add, and remove from the first, from the last. We can join two arrays together. So var my new array equals first array plus second array. So here's an example. If you have let array 1 equals 1, 2, 3, array 2 equals 4, 5, 6. Now you can say let container array, so this is my third array, equals array 1 comma array 2. So first array is going to be container array 0. This is how you access 1, 2, 3. If you want to access the first element of this container array, you would say container array 0 index 0, 0. So 0, 0 would give you this, the 1. 0. So let's take a look at this. And then we print container array. So container array would be 1, 2, 3, 4, 5, 6. Contains all those numbers. First array, container array 0, is going to be all the first numbers, 1, 2, 3. And 0, 0 would be just the 1. So I'm going to put this over here so we can play with it. This is something you can do also from your book, is you should be able to copy and paste from your iBook. Okay, and then what if I change this from 0 to 0 to 1, 1? What do you expect if I do 1? Oh, so we did 1, 0. So 1, 0 would be here. So what do you expect if we have 1, 1? If I do 1, 1. Not 1, no, that's bad. There we go, 1, 1. So 1, 1 would be my 5. So this is 0, 0. This is 0, 1. The 3 is 0, 2. Then so this is row 0, row, column, row, column, row 0, column 0, row 0, column 1, row 0, column 2, row 1, column 0, row 1, column 0, row 1, column 1, row 1, column 2. Okay, so we always index. These are two-dimensional arrays, and we index them by row, column. Don't think your book went into that, but something you want to remember is always index row, column. Okay? Some reasons that you would do this is, let's say that you have this array that has names and this other array has grades. So let's say this is this is a student number. So student number 1 has a grade of 90, and this one has a grade of 95, and this one has a grade of 86. Okay, so these are the grades. And let's say that I want to find out what grade does student 2 have. So to find out what grade student 2 has, or if I just want to print all the students and grades, then these would match. So 190, 295, 396, 386. So that's where I would use something like this. Okay. All right, so I'm going to stop there. This will be the end of the lesson for arrays, and then I'll do a separate video for a different type of collection called dictionaries.